So this will serve as your review for your exam. Please make sure to go through any of your notes and any homework assignments. So starting with number 1, when we subtract a number from another number, we're going to switch the order, and we would get positive 10, choice B. Number 2, so 6/7 when expanded into a decimal, we will set it up as a division problem. We need to go one more place in case we need to round. So 7 goes into 6 0 times, goes into 68 times for 56, goes into 45 times for 35, goes into 57 times for 49, and sorry about emails, goes into 10 one time. So when rounding, 0.857. For our next problem, the 6 is only attached to the 2. If there were parentheses around the 2, then we would, of course, raise the negative to the power as well. So we're going to have -2 to the 6th power would not be 12. So that definitely eliminates the first 2 choices. And since it's 64 and we negate, it would be choice D. When we talk about rationals, we want to be careful. So for our first example, all fractions are rational. This is an integer. All integers are rational. This is a non-perfect square. All non-perfect squares are considered irrational. So the answer is definitely going to be C. And this is a terminating decimal. Please, again, this is a very common question on the final. Do not confuse 3.14 with pi. Pi means pi. 3.14 is a terminating decimal. So please just be careful about that. When we talk about our multiplicative inverse, the first thing we need to do is we need to change this to an improper. So 3 times 5 plus 2 would be 17/5. And then we are going to take the reciprocal. The reciprocal would be 5/17. Remember, the definition of multiplicative inverses are 2 numbers that multiply to give us 1. For number 6, we will replace the values and we will treat the absolute value as a set of parentheses for a moment. Remember, whatever is inside the absolute value always comes out to be positive. Choice A. For number 7, we will replace again using parentheses, especially because we have some negatives involved. So we really need to be careful about that. So the exponent would occur first. That would be 9 times -2, which you can evaluate as -18. And then you can multiply these 3 values. So you have 3 negatives, which will stay negative. 2 times 3 is 6. 6 times 2 is 12. And we get -30 as our solution. Number 8 is going to be where we evaluate what's inside of the absolute value first. We get 7 plus -3 minus the absolute value of -5. Anything inside of an absolute value always comes out to be positive. Please do not make these 2 negatives a positive. Evaluate the absolute value first and then take the negative in front. 7 minus 3 is 4. 4 minus 5 is -1. When we expand a binomial, this is another common question on the final. We need to make sure that we multiply it by itself. 4x squared plus 6xy plus another 6xy plus 9y squared. The middle terms will combine to a 12xy. And so our final answer is going to be choice A. Very common question. Number 10, we will distribute the x into each term first. So 2x cubed minus 5x squared. Another common question. So I'm really getting you guys into the final exam mode. You can line up your terms to help you add together. So when all said and done, you're going to have 2x to the 3 minus 11x to the 2 plus 17x minus 6. So just be careful to match your choice, choice A. Another order of operations, so we will deal with what's inside the bracket first. So combining the 2 and the -7. Inside the bracket, we will get +9. We can also evaluate this exponent as 16. So this is 27 plus 48 minus 15. 27 plus 48 is going to be 75. And 75 minus 15 is +60. The next problem is a binomial, but it is not a difference of squares since x to the third is not a perfect square, but it is a difference of cubes. Cube root of x to the third is x. The cube root of 1,000 is 10. So we get the binomial trinomial combination. The roots go inside. We square the terms on the outside and their product in the middle. Since we started with minus, we go minus, opposite, and always end in plus. So our correct answer would be choice C. Here you will distribute the 5x into the binomial x minus 2. So we will get minus 5x squared plus 10x. The 3x and the 10x will combine to a 13x. Choice B. Here you will use your AC method after checking for GCF, so -10. Factors of -10 that add to -9 are going to be -10 and +1. So we will use a 1x and a -10x to expand our middle term. I like to put the -10 with the 2x squared and then the 1x with the 5. GCF is 2x. Since we already have the x minus 5, we have to factor out something. So we will factor out a 1. And our factors are x minus 5 and 2x plus 1, which is choice B. And you could always check this by using FOIL or the distributive property. For the next one, you're going to cube everything on the top first, including the coefficients. So 8, x to the 9, y to the 12. When you raise a power to a power, you multiply. The coefficients will reduce to 1/3, not 3/1. 9 minus 3 is +6, so that will stay in the top. And then 12 minus 14 is -2, so that will go in the bottom. And that would be choice A. In this, there is a GCF, and if you look at A, C, and D, that is also an indicator of a GCF occurring. We have a sum of cubes, so the cube root of x to the third and the cube root of 64. So don't forget to put the GCF out in front. That's a common mistake, which will lead you to the wrong answer. We'll square the terms, put them on the outside, their product in the middle. So I have a plus, which means I will go plus, then minus, and then I always end in plus. And that will definitely be choice D. So whenever you see a remainder, that's usually an indicator that you have to use the long division property. Please make sure that you have every term accounted for. So 5x squared divided by x is going to be 5x. 5x times x is 5x squared. 5x times -2 is -10x. Make sure to negate. So -3 plus 10x is 7x, and we're going to bring down the 4. 7x divided by x would be 7. So we already can see that C and D are probably not our answers. That's the beauty of multiple choice. So we're going to get 7x minus 14. Again, we will negate. And 18 is our remainder, choice A. Number 18 is a difference of squares. This is a perfect square and this is a perfect square. So there are your binomials, and there's really not much work you can show there. So whenever we have any sort of subtraction, we must distribute the negative. So we will have 4a squared b cubed minus 2a cubed b squared minus 5a cubed b squared plus a squared b cubed. The 4a squared b cubed and the a squared b cubed will become a 5a squared b cubed. So you can already probably eliminate those two choices. And then these two terms will combine to a minus 7a cubed b squared. And that would be choice A. Checking for a GCF. Again, this is an indicator of what your GCF is. So again, that's a nice way of starting your problem. So we'll end up with 9x squared minus 4y squared z squared. This is a difference of squares, 3x and 2yz. As long as your exponents are even, they are squares. We just discussed this. So again, the difference of squares will factor into. So this one's definitely out. This one's also out because they start with 9s. And these have the same sign. We need opposite signs. So choice D. This one, we will separate each term since we are dividing by a monomial, and then we will reduce. We will end up with 3x to the 6th minus 5x to the 4th. And we cannot reduce or simplify any further, so choice B. For 22, we will factor everything completely. So this will be 8x minus 4 and x minus 3, 4 minus x, and 6x cubed. The 12 and the 6 will reduce to a 2. The x cubed and the x to the second will leave with us with an x on the bottom. There is that a minus b over b minus a, so -1. So in the numerator, we're left with a -2. In the denominator, we're left with an x times x minus 3. So choice A is the one that is negative, choice C is positive. Okay, sorry, I am having a little email issue. There we go. Okay, here we are going to do a little bit of distributive property. So this would be 10x squared plus 6x minus 35x. So I already know I'm going to have a -29. So my answer is probably C, minus 21. And indeed, it is choice C. So multiple choice can be super helpful. This one's just a little practice with common denominator. So when you look at multiples of 20, 20, 40, 60 would be the common denominator. We're going to multiply by 3 top and bottom. We're going to multiply by 4 top and bottom. And we get 3 over 60, which would reduce to 1 over 20. Okay, for 25, we're going to factor. So x minus 5 and x plus 5, difference of squares, 5 minus x. So there's that a minus b, b minus a. In this case, you can see that they did not distribute in the answer. So choice C would be the correct solution. 26, again, a little more factoring. The x plus 4s will reduce, and we are left with x minus 4 over x minus 6. Complex fraction. So again, we will multiply by the LCD, which in this case is xy, just to kind of zoom in a little bit for you. Those will cancel, leaving me with 2. The x's will cancel, leaving me with 3y. The y's will cancel, leaving me with x. So that is going to be choice B. In the next example, we need to have a common denominator. I'm so sorry. I don't know why this is so small here. Let me, I didn't even realize. I mean, I'm sure you, there we go. So sorry about that. I just looked up and saw that. So the LCD here would be 5 times x plus 2. Okay, so we're going to have multiplication of x plus 2 top and bottom. And then here we will multiply 5 top and bottom to get that common denominator. In the first fractions, we need to use the distributive property. So x squared minus 3x plus 2x minus 6. And then we could see that we're going to have a minus 10. So we can sort of do a combination right away. X squared minus x minus 16 over 5 times x plus 2. We cannot factor that any further. So we will just leave our answer and just be careful when picking your choice. Choice D is the correct solution there. In our next problem, we will factor the second denominator to find our LCD. The LCD would be x minus 4 and x plus 4. So the first fraction just needs an x minus 4. Okay, again, distributing, we get 2x minus 8, and we can just add the 3 since it's a monomial. And we will then put that over that common denominator of x minus 4 and x plus 4. So we get 2x minus 5 over that denominator. And since we cannot factor or reduce, choice C. In our next example, we're going to get a 15x squared. So that would be our least common denominator. You can see the second fraction already has it. So we just have to manipulate the first. 3x top and bottom gives us 6x. And the last 5x top and bottom gives me 20x. Since it's all addition, we will get 26x plus 7 over that common denominator. Our next example is a little more complicated. We have x minus 3. So the left side is going to need x plus 1 to the top and bottom. And the right side is going to need the x plus 3 top and bottom. Okay, so again, we are going to distribute. We get x squared plus x. And then here we're going to get minus 2x squared minus, plus 6x. We'll do the minus after actually. So just 2x squared plus 6x. Okay, over that common denominator. The most annoying part is just having to write the denominator so many times. So we have to make sure we distribute and negate. So we will get x squared plus x minus 2x squared minus 6x over the denominator, which we already know. So negative x squared minus 5x over x plus 1, x minus 3, and x plus 3. Now you can factor out a negative x from the numerator, but even if you decide to do that, you are not going to get any sort of reducing. So A would be your answer. So remember, whenever we are dividing fractions, we must use keep, change, flip. Okay, so we will factor the first numerator to be 2x plus 5 and 2x minus 5. The second numerator is x minus 8 and x plus 3. 2x plus 5 on the bottom. And now for this trinomial, we'll use the AC method. So factors of negative 30 that add to positive 1 would be 6 and negative 5. So when we go and we expand, we'll do 2x squared plus 6x. And then plus negative 5x minus 15. 2x, we're left with x plus 3. Negative 5, we're left with x plus 3. So our factors are x plus 3 and 2x minus 5. So sometimes you have to step to the side and do a little math. The 2x plus 5s will reduce as well as the 2x minus 5s and the x plus 3. So x minus 8 is what we're left with. For the next one, we are going to find the largest square in 32, which is 16. So we end up with 5 times 4 radical 2, or 20 radical 2. The largest square in 8 would be 4, giving me 2 times 2 radical 2, or minus 4 radical 2. And since they are like radicals, 16 radical 2, choice B. 6 over 6 minus radical 3. So we will multiply top and bottom. We get 36 plus 6 radical 3 over 36 minus 3. We'll talk about this in our lesson on Monday in case you watched this before then. But with this example, we are using the conjugate of the denominator to create a rational solution. So remember, a conjugate pair we discussed last week on Wednesday, or this week, I should say, is the same binomial, and then it's just the opposite sign. So whatever we do to the bottom, we do to the top. 36 plus 6 radical 3 over 33. And if there is something common, we will reduce, in this case, 3. So 12 plus 2 radical 3 over 11. When you look at your answer choices, you can see that a 2 has been factored out. So in this case, 2, 6 plus radical 3 over 11, choice D. But if that's a little confusing, it will make a bit more sense on Monday. Distributive properties, so 7 times 12 would give us, 7 times 2, excuse me, would give me 14, radical 3. And then 2 and 5 gives me negative 10 times 3. So I get 14 radical 3 minus 30, choice A. All negative exponents go in the denominator or to become positive or vice versa. So in this case, because the entire 2x cubed, 2xy is being raised to the negative 3, we place the whole thing in the bottom. We will then apply the exponent. So we get 8x to the 3, y to the 3. The 8 and the 2 will reduce to a 4 on the bottom. And we are left with 1 over 4x to the 5, y to the 3, choice D. Sorry if it's a little hard to see those answer choices. With 37, because they are both under the radical, we will divide first. So we end up with 16 x to the 4, and then over. So I really should have made this one big radical, y to the 8th. They're all perfect squares. So we end up with 4x squared over y to the 4th, which is going to be choice A. Again, we can take the reciprocal of the entire fraction to make the exponent positive, and then we raise everything to the power. 25 over 4k to the second power. And that should be the end of our review. So please, again, review all of your notes, homeworks, and we can go over some on Monday as well.